Welcome to Homework Lib.
Over here I don't have access to the ALEKS data table, but what we can do is employ and the free energies of formation of these compounds in order to get the values. And you can replace the values that I'm going to provide here with the ones from the ALEKS data resource. I'm going to give you the reference for each of them. So for the following reaction, in order to be able to calculate the equilibrium constant, what we're going to get is that the delta G standard is going to be equal to minus RT logarithm of my equilibrium constant. So the equilibrium constant is going to be essentially the exponential of minus delta G of formation divided by RT. Okay, so the delta G standard of this reaction is going to come from Hess law, and this is going to be equal to the free energy of formation of CCl4 in gas phase minus the energy of formation of carbon in the graphite solid form minus 2 times the energy of formation of Cl2 as a gas. So remember that for elements on their standard state, the energy of formation is going to be equal to 0. So for graphite and for chlorine in gaseous state, the value is going to be equal to 0. So the energy of formation, the energy of this reaction is going to be directly the energy of formation for CCl4, which is going to be equal to 2 minus 106.7 kilojoules per mole. Remember, this is just going to be a value that I found online for this reference. In your case, you need to plug in the result from the ALEKS data resource. So now with this information, we can proceed. The value for the equilibrium constant is going to be the exponential of minus the value for delta G, so minus 106.7 kilojoules per mole. In this case, we're going to transform directly to joules per mole multiplied by 1000 divided by the gas constant, 8.314 joules per mole Kelvin, times the temperature, in this case 25 degrees Celsius, which is the same as 298.15 Kelvin. So the result of this is going to be giving us 4.944 times 10 to the 18. So again, just the important part of information, check up this value for the delta G of formation, just for it to match up with the actual value on the ALEKS data source, and then you can substitute into this equation and get your result.